What's up, people? How you doing, chemistry? Welcome back to the Dirt Bike Shed. All right. What are we going to work with today? We are going to work with single replacement reactions. That's right. You've been working on double replacement reactions, but today we're going to back it up and we're going to do single replacement reactions. Single replacement reactions, which aren't any easier and aren't any harder. I don't know, maybe they're a little bit easier. Let me adjust the camera here and get comfortable. Okay, single replacement reactions. Here we go. Let me show you one we're going to do together. We're going to take some copper, some solid copper, and we are going to drop it into, that's supposed to be an S, okay? And we're going to drop it into a solution of silver nitrate, okay? And that's going to be a solution, so that's aqueous, right? And we are going to take a guess as to one or two things. One, will there be no reaction? Or two, will we need to finish this and say, okay, let's look over here. Copper's by himself. Copper and silver are two metals. So if there was a single replacement reaction, that means that this silver would be replaced by the copper. Okay? Now, for this copper to get into this relationship and break up the silver and nitrate, the copper would have to be more attractive. Would have to be more attractive to the nitrate than the silver was. Now, luckily, we can look in our chemistry tables and we can look, let's see what page we're on here. I think this is page 7. Page 7. Let me see if I can move this table around here. Yeah, we're on page 7. Now, on the left side of the page, you'll see there's an activity series, and that tells you how active the metals are. Now, these are the metals down here, and at the top of the page, those are the halogens. We'll do those later. Not any harder, not any easier. Now, let's go back. We were talking about who is better looking, who is more attractive to this nitrate. Is copper more attractive, or is silver more attractive? We can look right here. Here's their list. Down there at the bottom are the unattractive metals, or the least popular. And as you work your way up to the top, you get up to the most attractive and the most popular, okay? Down here at the bottom, ooh, look who's very low on the social ranks. Boom, silver is not very attractive at all. And look, above it is copper. So copper is more reactive. Copper is higher up than silver. So silver, copper, look, nickel's more reactive, cobalt, cadmium, iron, chromium. But we're only worried about these two guys right here, right now. Silver versus copper. Who's the most attractive? Copper, because copper is higher up on this list. So if we look at this chemical formula, we would say to ourselves, yes, copper is more attractive, so copper is going to now be with nitrate. Now, you know copper usually has a charge of +2, right? So we would be making copper to nitrate. Remember, you'd have to write this correctly. And who's going to be alone now by themselves? This silver. This silver's been dumped. It's been broken up with by nitrate. Now the silver would be by itself. So the silver is now the solid, and the copper nitrate is aqueous. So what does that mean? It means if we had a test tube like this, here's a test tube, and I'm going to put some silver nitrate in it. And the silver nitrate is clear. Okay, it's just going to look like water, but trust me, it's got silver in it, okay? I use a lot of, this stuff is expensive. Do you know why it's expensive? Because it has silver in it. That's why it's called silver nitrate. And silver is expensive. All right, so I've got some silver nitrate here. AgNO3, right? This is what I've got in the test tube. I'm going to put some copper in there. Copper, I've got some little strands of copper. So here we go. I've got one right here. See this copper? Can you tell that that is copper colored? It's copper. All right, there you go. There's a good look at it. I'm going to take that copper and I'm going to shove it down in this test tube. And what's going to happen is anything that is below the surface of the water, that copper that's down there in the water, that copper is going to kick out the silver. And then the silver is going to become a solid. So what's going to happen is on this, in this test tube here, you'll see a copper color up here, but down in the water where the chemical reactions occurred, you're going to see this copper color turn silver because you'll actually see the silver from the water come out. We'll take a look at that later. I may need to let it sit until tomorrow. All right, let's try a couple of more single replacement reactions. Let's try one right here, and you can try it by yourself, but just hit pause on the video. What if I had some sodium, and sodium's not a good choice. Let's not do sodium because you know what happens when we put sodium in anything wet, it'll just start fizzling. So let's see, what if we had some, I don't know, magnesium. And I dropped it into a test tube that had some copper sulfate in it, okay? Let's see if magnesium would replace that copper. Okay, no problem. We're going to look here on our tables. Here's magnesium. Magnesium's pretty high up the list. You see magnesium right here? And if we look down here, we will see way down that copper is actually lower than magnesium. Look, here's magnesium right here, and copper is all the way down here. So magnesium is much more attractive than copper, okay? So we would expect a chemical reaction to happen here. So the magnesium will replace the copper. So you will have magnesium sulfate, and that is the correct formula because magnesium's +2 and sulfate's -2. And then you would have copper left alone by itself. So the copper would be a solid. This would be aqueous. We knew that these were already, this was aqueous because this was just a solution. And we had dropped some solid magnesium in there. All right, and look, this one's already balanced because we didn't have to change any of the formulas. Let's try another one. Let's try, what if we put some calcium? We have some solid calcium, and then we find a test tube. And this test tube has some, I don't know, potassium nitrate in it. Potassium nitrate. And that will be aqueous. Would this calcium be able to replace the potassium? Let's see. Let's look at our tables. All right. We're looking for our metals right here. Here's calcium. Here's calcium. Calcium's right there. And ooh, look. Potassium is higher than calcium. Here's potassium up here. So potassium is better looking than calcium. Potassium is more attractive than calcium. So if calcium was around potassium nitrate, this would not break up because the nitrate is already more attracted to the potassium than it would be to the calcium. So if you saw an equation like this, just write NR. Okay? Here's what I'm going to do. I'm going to post up 4 problems right now in this video, and I want you to try to finish them and balance them. Or if you don't think anything would happen, just write NR like I did at the end of this equation. All right, I look forward to seeing what you turn in. There's one to try. And there's another one to try. So that's the second one. I'm going to give you 2 more. Here's the third one. Solid barium dropped into a solution of potassium hydroxide. Would that do anything? Would that happen? And the last one is solid zinc dropped into a solution of iron 2 carbonate. Would that produce a single replacement reaction? I'll have the answers posted to these Friday morning. I will post them right after the assignments due. Good luck with them.